We have state. Now we need a neural network to represent our Q table. This is where we need to start merging some code. Here's my cartpole project. Here's my neural network project. I have a neural net. Notice some of the files are the same. We have a random class in both cases, vec class, matrix class, and string class, and error. Those are all the same between my projects. Oh wait, you didn't have vec or matrix in the other one, did you?
No.
Okay. Well, we're going to need those. So, in fact, we need everything. We don't want to copy over main. That'll stomp over our main one.
You need JSON, vec, matrix.
Basically, you need everything except for main. You don't need baseline. That's just an example code.
You need normalizer.
Oh, you don't need imputer or normalizer. That's some stuff I included because it's going to be useful later in this semester. For right now, I think it's going to be easiest just to copy it all over. Copy baseline.star, error.star. Nope. Cartpole, CPP, source, baseline. I've already got error. I'm going to need JSON.star. And I'm going to need neural net. Okay, I'm going to go through and basically copy over all the stuff I need. For the record, because I'm recording, you'll get this. Here's what you need. You've already got base. You don't need baseline. You don't need error because you've already got it. You could copy imputer, wouldn't hurt anything. You definitely need JSON and matrix and neural net. Don't need nomcat, but it wouldn't hurt. I'd just copy it over. Same with normalizer. You've already got rand. You've already got string. You need this if you copied over normalizer or imputer. They go together. And you do need vec. Got that? So you definitely need vec, matrix, neural net, and JSON. Okay. Once you've got that, we'll come back to our other project. Cartpole, CPP, source, makefile. I will edit my makefile now, and I will add to it matrix.cvp, neuralnet.cvp, JSON.cvp, and what was the other one? Vec.cvp. Okay, great. Now I've got all that stuff. By the way, all this stuff I did over here with vec wouldn't have worked until I copied over that vec class. I'm doing things way out of order here. I apologize for being confusing. But now it will all work. And if I build it, surely it will just build with no errors except for those typos that I made. Angular velocity. Okay. There, now I feel better. Now we've got some code that might work if I press compile. What's that? Oh, okay. Well, I'll leave it alone for now. Okay, now we need a Q table. We're going to use a neural net for a Q table. I say we just make it a member variable of the controller class. Does that make sense to you? Because we've got to stick it somewhere. It's got to persist. The controller is the one that's using it. It just makes sense to me that it's going to go right here. Neural net m underscore, how about nn? Or q would actually be more consistent with our pseudocode. Let's call it q. So I will include neural net.h. Now we've got a neural net named q. Okay. In order for that to work, we need an initializer. Actually, I think it has no parameters, so it would work without one in C++. But that'll take care of it, right? let's look and make sure. Okay, neural net.
Q, not N, not Q.
Oh, okay. Here's my neural net class. It does have a default constructor, so we don't need an initializer, but it doesn't hurt. It is just Q, not M underscore Q. Okay, there we go. So now we have a neural network. We also need to initialize this thing. How do I know that? Because in the other example, look at how this neural network is used. Hopefully you've looked at this by now. This is not the same example as the one you get. Web assignment 1, neural net CPP. There, now it is. Maybe. Okay, main. This is the example you've got. Okay. Have you looked at this code yet? Any trouble understanding it? Here's what it does. It makes a pointer to a neural net. If it's the first time, there will not be a file named model.json, so it's going to go down this path. And we're going to say, making a new model. Here it makes a new neural net. And then it adds a bunch of layers to that neural network. And then it initializes the weights of the neural network. This is all necessary stuff. I'm not going to explain it in great detail. Suffice it to say, microphone shift off. Suffice it to say, you have to do all this stuff. So you have to add some layers to your neural network, and you have to call initialize. We're going to do that. Then this example trains it. Here's an example of training it. We call train incremental a whole bunch of times. And then we save the model to a file. Why? Because that's a darn useful thing to do. The next time we run, it just loads the model from a file and spares itself from having to train again. See how that's useful for what you're trying to do in this assignment? Okay. Well, that's that. So we're going to need to put this kind of stuff all inside of our controller. I hope nobody's mad that I'm doing this all in class after you wrestled with it all weekend. I'm sure you learned a lot of things that were really good for you and know it much better than do the people that are only going to start now. So in this case, we're actually calling it Q. And instead of making a new random number generator, we're just going to use m underscore rand there. And these are all going to have to be changed to periods because we're doing C++. But essentially now we have made a new neural network. They're called the constructor right there. We've added a bunch of layers to it. We've initialized all the weights. And now we're ready to go. We're ready to do all the stuff that we do in this example right here when we train it. And that'll train our Q table. Okay. Now we have a Q table. Let's come down here to let Q be a table of Q values. Well, it is. So we can just get rid of that. And let's see, we do the action, get the state. Now we're going to start doing this kind of stuff where we query the Q table and write to the Q table. Okay. Whenever we write to the Q table, we're just going to call train incremental, just like it does right here. And we're going to pass to it the input, which will be the state, target, which will be the Q values that we want it to come out of it, and some learning rate, which will be 0.03, unless you want to fiddle with the numbers and try something else. Okay? Whenever we want to read from the neural network, we will do what we do down here in testing the model, where we create an input vector, we pass it to the neural network and call forward prop, and it produces a prediction, and that gives us an output from the neural network. So that should be everything you need to know to code up this part of it, the equation part of the code. And then once you've completed that, then you're done, and then hopefully it all works. Okay, yeah.
Any suggestion on setting number of bit layers or
Yeah. I have to admit, I have not done this assignment before myself, personally, and so I did not know the number of layers. I arbitrarily guessed these numbers because I thought they might be good. I'm hoping they're good, and I'm hoping that one of you can confirm that by getting it working and then tell us all, yay, it just works. If not, I hope that that person who gets it working will say, I had to tweak these layers a little bit, and here's my numbers, and then we can all switch to your numbers. So let me tell you how to interpret these. This neural network has 1, 2, 3, 4, 5, 6 layers. First, it has a layer of linear weights that go from 3 to 10. Then it has a layer of tan H nonlinearity units. This number must always match that number because they feed into each other. Then there's a layer of linear weights that map from 10 units to 8 units. And then a nonlinearity, then a linear layer, and finally I'm outputting a single value. The only numbers you're going to change are this input number needs to match the number of values in your state space. Do you remember how I had 4 values in my state space? So if you have 4 values, you're going to want to put a 4 there. And
include action?
if you include your action, now this is actually something we need to discuss. Does the action go on the input or does it go on the output?
Should go on input.
The answer is either could be done. I think the input is probably the most intuitive, so I'm going to change that to a 5. There, now this is the topology that I think you want. Okay? Another way to do it is instead only feed in the state, and for the outputs, pick one output for all 5 possible actions. Does that make sense? So if you're doing discrete actions, you can say, here's my state, and it'll say, oh, well, the value of doing action number 1 is this, and the value of doing action number 2 is this, and the value of doing action 3 is this, and the value of action 4 is this. And that way, I'll, in one shot, know the value of all my actions. This is one way to do it. This is another way to do it. I'm kind of more partial to this way because now we can make our action continuous. I don't like the idea of discrete actions. I like the idea of continuous actions. So I'm going to put my actions as a single value on the input, and then it'll tell me the Q value for doing that particular action. Yes?
But in one action at a time, we can only apply, I mean, in the vocab world, we can only apply one action at a time, right? That means we can record one state and one action.
Yes, that's true. So here's what that will affect you when it comes time to train your neural network. When you train it, where's the example? When we call train incremental, you pass to it the state, and you also have to pass to it the target values. Now the target is the new thing that you want to put into this slot in the Q table. Now if the only thing you did was try action number 3, then you only get out the value that should go in action number 3. What do you put in the other 4 slots? I would put what's already there, because that way it's not going to change anything. So you could query it first and get all 5 values, and then you could calculate the one for the one action you actually perform, and then you would update just that one action. Does that make sense? Okay. So could easily be done either way, and I've seen success done both ways. I had one student try both ways, and he claimed that having the 5 outputs, meaning he discretized the outputs and calculated a Q value for all 5 outputs, he said that worked a little bit better for him. So maybe that's, if you want to take that advice, that's the way to go. I personally don't like that because continuous just feels cooler to me. So I want the continuous way to work, and I don't have enough verification on it yet. So give it a try and see what you find out.
So how do you pick next action when you're doing continuous now? Because there's an infinite number of
There is. And that's something you've got to wrestle with. We pick random actions otherwise. I guess in this case you draw from a Gaussian distribution or something like that. Unfortunately, I'm overtime, right? We go till 9:25? Okay. Wow, I wanted to cover this many theoretical topics. I didn't even hit one of them. Sorry. We're going to talk about this stuff next time, but I think the practical stuff was really good and important. So thanks for coming. Please ask lots of questions. Start hammering the forum now, because I want to get this thing off the ground. And we'll talk some more on Wednesday.